All right, so a problem for us to look at static friction on. So we have a box in the bed of a flatbed truck. We have the coefficient of static friction and coefficient of kinetic friction. What's the maximum acceleration the truck can have without the box slipping? And then what is the friction force if the acceleration is 2 meters per second squared? So truck, box, let's say our truck is, this is my truck, it's terrible, I'm sorry. Ultimately, all I care about is the box, oops. Let's say this truck is moving, or going to move at least. Oh dear, what have I done? There we go. Let's say this truck is going to head to the right. Now, we're looking at the box specifically. We don't want the box to slip. In order for the box to move with the truck, so for the box itself, there needs to be a force of static friction in the direction this truck's going to head in for the box to move with the truck. So to get the truck moving to the right and get the velocity of the box also moving to the right at the same speed to move together, there needs to be static friction that's bringing the box with the truck. mg, force of gravity, downwards, normal force, upwards. So the maximum possible static friction, mu times n. We're told the coefficient of static friction is 0.4. We know, analyzing just the y direction, that the normal force needs to equal mg, because the box isn't going to accelerate vertically. So the normal force will be the 100 kilograms times g, 9.8. If I calculate this out, the biggest possible static friction force on this specific box in this situation is 392 newtons. So this is the maximum value possible. So revisiting the question, part A wants to know the maximum acceleration the truck can have without the box slipping. Well, the truck's acceleration is going to be the box's acceleration if the box is not slipping. So in option part A, we're taking this box. I don't really need to redraw the free body diagram, but I know the acceleration of the box, as long as it's not slipping on the bed of the truck, this acceleration, oops, not slipping, the acceleration will be the net force in the x direction divided by the mass. The acceleration of the box specifically is going to equal whatever the static friction force is while it is not slipping divided by m. So the acceleration of the box will equal the acceleration of the truck. Since this problem, this portion anyway, is asking for the maximum acceleration of the truck to keep the box from slipping, that means I can put in the maximum possible value of the static friction force, divide by the mass, and this will be the maximum possible value of the acceleration the truck can have, because that will be the maximum acceleration the box can have without slipping. Now technically we have two sig figs, so I would say 3.9 meters per second. That's the maximum, the biggest possible value of acceleration the truck can have, and the box will stay exactly in the same point on the bed of the truck. It will not slide. If the truck accelerates faster than that, the box will slide, and then we would have to change our free body diagram to account for kinetic friction. Part B, if the acceleration of the truck is 2, what is the friction force on the box? Well, this acceleration we just calculated represents the biggest the acceleration can be. So 2 meters per second squared is smaller than that. It is still true that the acceleration of the box in that x direction depends upon the net force in the x direction divided by the mass. It is still the force of static friction over the mass. But this force of static friction is not the max. We can say the force of static friction on the box needs to equal the mass of the box times the acceleration the box has. So since 2 meters per second squared is smaller than 3.9 meters per second squared, we know the box is not going to slide. The force of static friction is just going to be the mass of the box times this acceleration, so 200 newtons. This force is whatever it needs to be in order to give the box the acceleration it has. But we do need to know first that the friction force is not exceeding the maximum possible value. So kind of a multi-step thought process.